All right, good morning, everyone. Uh, just a confession before I start. I'm in between you and your lunch. Second, you may see some overlap, but that was not planned. Normally, we do it in two different rooms with two different audiences, right? So we talked a lot about the requirements. So normally, this is how we do the requirements. Okay, again, requirements. Let's put it this way. So requirements normally are just the needs and wants that move the current state from a future state of a system or the overall ecosystem, right? So we normally categorize into three things. We categorize them into the business requirement, we categorize them into the user requirements, and then user requirements further broken down to the functional and non-functional requirements, and then we talk about the system requirements, right? So in each requirement, we start from the very high level, and then we move down to the medium level requirement and very detailed or low level requirements. And then from the needs and wants, which is bulk of wish list from different people, we kind of like rationalize them, we look at those, and then we prioritize them. That pretty much becomes your product backlog. And this is how we normally drive the whole agile process. And once our product backlog is built, we kind of like move into the overall DevOps model. This is what we're going to talk about. But before we talk about that one, normally let's look into how we do all these requirement gathering stuff. We do kind of like identify the stakeholders, we build common vision, and then we kind of like define common goals. So everybody buys into the same architecture, same solutions, and then we perform the focus groups conversations. We kind of like do workshops. We gathered all these requirements during the workshop process. We do common one-on-one interviews with the stakeholders, and we really come up and try to understand how they're running the processes today or systems today, and how they really want it in the future state. And then after the interviews, we do a lot of system studies. That means which the systems are part of the overall scope, or the integration that needs to happen. We study different interfaces. We see what the inputs are. We see what the outputs are, and then we try to understand how the requirements should be laid down, and then everything moves from there on. We also do some kind of like surveys and observations as well sometimes, but it's not very common what we do. Most of the time, it's like system studies, focus groups and workshops, and that's what we do. And once we move into the overall delivery model, so we kind of like start off from the net validations. So the net validations, we write the code, and remember, the DevOps processes should not just only be the build process. It should be also taken towards your network as a code process as well. That means you'll be writing code for your change management. You'll be writing codes for the port turnups. You'll be writing code for the maybe a VPN configuration and all those kind of things. So they all is kind of like utilizing the same dog food for your own process. So with the same process that builds the system, NSO, its ecosystems, integrations, service packages, everything that we talked about so far and you have been listening about, we not just build only that, we also want to have it geared towards the network change, the day two operations as well. So this is where you see the second piece of it, where I say you write app code, you write the test codes, you write the infrastructure as a code, everything you write it, you check it in, and then everything pushed out to the repository. From the repository, you guys have different automated jobs that would just pull the code down. And then all these changes, then we do the static code analysis, different standards that you have defined within the Sonar Cube or whatever the tools that you got. Then we build the code, and during the build process, we run all the JUnit tests over there, and different unit tests, and then we move on to the actual building the virtualized environment. That just not the platform that is going to test your system, but also it can have a virtual devices as well. So I don't know if you guys heard about pets and kettles. The concept of pets and kettles is DevOps is the pets are fed with the hand, and the kettles are just at your discretion. They can come and go all the time. So that means there are going to be systems that are going to be built for the physical stuff. It's going to stay. You cannot. Those are the pets because you fed them with the hand. They cannot be disposed of. And there are going to be the systems which are treated like a kettles. Means your virtual devices, your NetSIMs, your CMLs, VIRLs, all those virtual stuff that you spin up on demand, and then you do the stuff on those. And then we deploy the code into those containerized environment or in virtual environment. Then we spin up more automated test cases, which are geared more towards the end-to-end and system testing. And then we do the security analysis, and we push off the code back, into the binary repository. And from this point on, it's ready to deploy to be into different environments like your QA, dev, pre-prod, prod, what have you. So during all this process that we run, it can be this process can run multiple times a day, multiple in a day or hourly, depending on how frequently you do the code writing and you check in the code into the environment. So how do we solve all these kind of like the processes? How we model them? What the tools and technologies that we have available? So normally internally, what we use is we call it software platform for accelerated development and evolution. It solves 3 problems for us. The first problem it solves is, in fact, it provides a single platform to do our all automated testing, our the development, build, all that kind of stuff. Second, it provides us a platform for the collaboration for different teams, and that can be the customer as well. So in case of the code development, we can leverage this platform for the code develop, and then it will all go through the same pipeline, same process, same ingesting of the code. And the third thing is solve is also standardizing our AS deliveries. So we're coming up with defining a process that everybody follows the same process, same artifacts that we have to develop, and it goes through same steps every time we check in the code and when we have to release the code. And normally this platform has the tools like Rally, which help us manage the life cycle of a product. And then it has a CSDL process, which is our really security analyzer. It's kind of like builds, it tests code for the various vulnerabilities, and then it identifies those vulnerabilities, and it's kind of like its overall security process in there, compliance and security. And then we have something called the Sonar Cube. Sonar Cube is really kind of like a static code analysis. Static code analysis, you do it before even you have to even build a code. These kind of like a adherence to standard sets of standards that you have defined for code, whether spacing, whether using for loop in a certain way, or the nested loops and all those kind of things, it will identify out of time. We'll also try to identify the bugs in the code ahead of time. So all these kind of like templates are defined as Sonar Cube. So we run it through the Sonar Cube, and we get the first cut of the code. I would say validation. Then we have the stuff like the Jenkins, which is the heart of our overall DevOps process. And this Jenkins is nothing but a job scheduler where you have multiple plugins enabled. You write these, enable these plugins, and then there are certain other plugins that you can use. For example, you can use Jenkins pipelines, and we'll talk about that one later, which is kind of like is a small workflow automation for your build processes, like how your code moves from one stage to a next stage, and what are the different steps that run in each stage. So that is really defined by the Jenkins pipelines. And oftentimes we are asked, when we're moving to this overall DevOps model, where you have a people, processes, tools and technologies, and collaborations, feedback, KPIs, everything you have to meet, what are different roles that we normally would people have? So the most important roles that we follow within our deliveries and within our Cisco, the solution architects, which are kind of like own. Sometimes from the customer side, we do have the people who work in the product owners, because we all understand in an agile model, which goes hand in hand with DevOps, although DevOps and agile do completely two separate things. But the role of the product owner is very important. So that's a person who owns the product, the solution, and defines the success of the product as well, right? And the rest of the team are working towards building that vision or the same product, right? So sometimes we have challenges on the where the customer may not act as a product owners. So our solution architects, they act as a product owners, and their responsibility is completely drive the use cases, drive the products, prioritize them, and help the rest of the agile team through the process of building this product. And then they all use kind of like a different type of tools. They use Jira, Rally, Then the second role is obviously the software developer roles, which is these are the guys who really build the code. Software development could be, not just only the services code or service packages, but also the people who are, collaborating towards building the overall CI/CD model as well. So all these kind of like if the resources fall into the software developer roles. Then we have project manager, of course, to track the timelines and deliverables, that kind of stuff. And then we have a separate test engineers which are working, building the automated testers, and we will share the framework that we use today to test the code end to end. So from the overall kind of like NSO spade environment perspective, so this is how we have done it. We have certain fixed services, then we have certain services that are on demand, and then there we have services that are only related to the life of a build process, right? So in the fixed services, we have things like Jenkins master pipelines, then we have the Git, we have a Sonar Cube, and all those kind of like our fixed services that we have today. And on-demand infra services can be all your, and this is where the the terms pets and kettle comes in. So you have the virtual devices that may be spun up on demand. Then you have a physical devices that you may not have the discretion of kind of like decommissioning them and recommissioning them on the demand. And then we have certain processes that we do during our build process. Those are the different containers. Some of the containers are kind of like we use NSO in a containerized environment. Then we use Rasta, which is built based on robot framework. It's a testing framework, very common, a popular open source tool. But what we have done in Rasta is we've taken the robot framework, and then we have built a library around it. My friend Prashanth is going to talk in greater detail about the Rasta framework. So these are kind of like the overall, the tool sets or platform that we have today that we're leveraging for our NSO CI/CD environment. So this is one of the use case that that shows how a day two or a network as a code would really work. So the term network as a code really came from infrastructure as a code, right? Or software, because the software is all about the building code. So from that software code, the term infrastructure as a code took birth, and then now we're talking about the network as a code, which is nothing but making sure all the config changes that you're pushing down to the devices are thoroughly tested, and before they are make it to actual production environment or whatever the target system would be. So we have a different steps in our CI/CD model. We talked about the continuous development in the previous presentation. We talk about the integrations. We talk about the testing, continuous delivery, continuous deployment, and then definitely continuous feedback as well for measuring your KPIs. And your KPIs could be like your mean time to deploy, your mean time to resolve certain issues, and that kind of stuff. So we took one of this use case, which is called the CPE parameters update. And then we model them along the process, like where different things fall in this overall CI/CD process. Let's say you got the development CPE parameters config. We validate this config. We develop these kind of services packages. Then we check in the config and the service packages all into the Git. So it pretty much covers your continuous development model. So this is what the life of a software developer is, or the tester is, or the person who will get involved from the network operation side. So they will just continuously keep on doing this, and then the rest of the things are going to be taken care of the system itself. So you have integration process where we build all this environment, and then we update the device manager list. In this process, we provision the test bed. We will talk about the test bed just shortly after this slide. And then we push out the page configs, and then we move into the continuous testing model where we just run all these tests end to end. Just in the interest of time, I'm just going to stop talking about this eye chart, and I'm just going to hand out to Prashanth, who's going to walk us through the complete automated testing framework.
Thank you, Rashid.
All right.
All right. Okay. Okay. Thanks, Rashid. So I'm going to spend some time on automated test framework that we have come up with, and we call that as Rasta. And then, of course, I'm going to go through the Jenkins pipelines and how exactly the build automation and test automation are stitched together with the Spade platform and with the delivery to the customers. So Rasta, a robot advanced services, Cisco is set automation framework. It's mainly built on robot framework, which Python community as an open source project came up with. And then we have built a set of libraries written in Python for certain use cases. We started with a very simple use cases like L3 and L2 VPN as customer use cases. We have written some Python libraries which will help us in testing the service packages that we deliver to the customer. And then we formed some keywords which are in natural language. So the problem that you're trying to solve was, even before the test automation framework, every customer engagement that Cisco AS was handling has its own test automation strategy. Like some people go with an Excel-based automation, and then some with Java or some Python-based native unit test and regression test frameworks. So what we wanted to come up with a unified approach where all the testing resources or the test people are following a keyword-based test automation strategy, where you just have to drag and drop and plug and pin the keywords or the libraries, different libraries which are already built in, and then frame your test case and execute them. So it's absolutely flexible for the people who are not programmers or developers. So you just have to go through a pool of keywords or the libraries. You just have to drag and drop the keywords into the test cases and then execute them. So that was the prime use case, covering the test automation for both programmers and non-programmers. And Rasta as a platform, it covers 3 phases of test cases, starting from creation of test cases, executing them, and reporting them back in both HTML, XML, or in any other format. So pretty much this is the architecture of the platform, where Spade as a platform, we have the build automation platform in Jenkins, and then so the framework fits in here. So this is the robot framework, which is open sourced by Python community, and then we've added a few more libraries which are specific to NSO, and we call that as Rasta. And then for every customer engagement, we always have some of the other custom libraries that have to be written by the resources, right? So all those custom libraries will be fitting into a keyword library. And then we have some test reporting libraries as well, which support HTML and XML formats. And then these are the key libraries which are written. So if you want to go with the UI-based test automation, then we have Selenium integrations with JSON RPC, JSON Unicorn, and all the northbound interfaces and the southbound interface which NSO currently supports. So these are the libraries which the actual keywords written by a robot and Rasta framework will be interacting with to the actual devices which are under test. And the devices can be anything. It can be NSO itself, or it can be an iOS or a EAC or a confd, or to that it can be a plain Linux server as well. So the device can be anything. And these are the libraries which Rasta or robot framework will be using and executing the tests upon. Coming to the framework syntax, so as I said, the framework is flexible enough, so we have a choice of going with either a TSC format where you have your table, you have a tabular structure defining your test cases, and then you're going to put your values there and define your test cases, or you're going to go with an Excel-based format or define your keywords in a very plain text file. We call this as a robot file, where you plug and play all your keywords. So you said this one, use testbed or connect to the device. These are the keywords which are developed in Rasta framework. So previously, what we have to do is to have the Python or the Java or any programming language-based implementation for such kind of use cases across your test cases. So Rasta as a framework, what it does is it removes the implementation part of it. So this implementation has already been done as part of the framework, and we attach a keyword on top of it. And we say that, okay, now you have to just use this keyword in your test case and the Python function which has already been implemented, right? So that gets called and does your job of testing. So looking at this robot file, so the best part of Rasta or robot framework is this. It increases the readability and the openness towards your test case execution or test reporting, right? So anyone who is familiar with your project or customers who are looking at the test cases will seriously understand just what's going on in your test cases. Like these are so much human readable and then less non-programmatic. And then comes the Rasta library. So the next part is when once you have too much of keywords, all your Rasta test cases defined, and you start delivering it to your customer. And maybe there might be some point of interaction where you would want to reuse the set of keywords or set of test cases which are already been delivered to some of the customers, or you want to put that in a community and then start making a generic use case out of it. So that's when you call them as a resource file. So you say connect to NSO via CLI is a very generic keyword which can be used across different customer projects. You're going to put that in a resource file and can be used across the test suites or across the customer engagement projects. And that's how you contribute back to the community. So Rasta right now is a community which is spread across large amount of people in Cisco AS. And so when someone feels like a keyword which can be generic enough and reused across the projects, that's when you can put that in the resource file, use it in your different test suites, or contribute back to the community, and then you can have the pool of resources. So what the test resources have to do is to just go through these resources files and then drag and drop what is the keyword that you're going to put. And these keywords can be a collection of keywords or a collection of Python libraries. It's up to the person who's writing the test case. I'm going to run through a demo of time permits, and then we can have questions. Yeah. Okay, so I'm going to start with Jenkins pipelines. So this is the build server, a very simple project which I've built for this demo purpose. And these are pretty much the stages which we cover or we follow whenever a code gets checked in by a developer or some test resource. It starts with creating a network. So all the build automation and test automation is in a Docker environment where we start with creating a Docker, and then so based on what NSO version your customer engagement is dealing with, so you're going to spawn that particular Docker on the fly and then download and install those particular network element drivers. And then we create the devices. So if the engagement is mostly on iOS and Junos device, something like that, you want to create those devices. Or if you already have the real devices, you're going to attach that to your test bed. So that's what this stage does. And then you're going to do some static code analysis, do a code review. So if you think, is this the code which is present in the Git right now, is it valid enough to take it to the testing stage, or you're going to do some code review there. And then you install your NSO service package into your NSO environments, the Docker, and then we load some basic configurations which are needed for Rasta test cases to be executed, and then execute a test case and publish back the results. And if everything goes well, you're going to publish your release back to the Cisco Artifactory. So pretty much these are the stages that each time you push any change to a Git repository gets executed sequentially. And yeah. And this is a very simple Git repository which I've created. So consider this as your service package Git repo, and you have two things. One as NSO test. It's a very simple service package, and then I have something called as tests, and then there is a Jenkins file. So all the stages which are present over here are actually implemented in Groovy script, which is readable by Jenkins, and the implementation of that is this Jenkins file. So click this, and you see that each stage has been implemented here. Docker network creation, and then you have this NSO 4.6 Docker creation. So all the functions that you see here are downloading init or creating an NSO Docker. These are the functions which are pre-implemented, and you're going to put all together in a Jenkins file and get the Jenkins pipeline ready for your project. And then and we also have some documentation on, we call that as a Cisco NSO pipeline library. So where we defined all NSO specific functions like downloading an ad or doing a packages reload or adding a devices to NSO. All these functions are predefined and written in Groovy language, and we call that as an NSO pipeline library. So here you start having some tutorials on how to write your own pipeline and defining various stages in your Jenkins files and do what all you want as part of your customer engagement project. So all the pipeline steps, starting with you know, how to start NSO from Jenkins, how to stop NSO sitting in Jenkins, all that has been defined on top of Jenkins. And then you just have to drag and drop all these functions and put it in your Jenkins file. And that evolutes to this kind of a Jenkins pipeline. Yeah. And then comes Rasta framework, which I was talking earlier. So where we have some keywords which are already defined, and this is the documentation, which is a nice place to start with. How do you onboard the project with both Spade and then Rasta, and then how do you start writing a very small test case and then going to the complex test case and have all this test case in your Git repository, and then integrate that with the Jenkins pipelines. And if you're going to take a look at the Rasta keyword index, so these are like close to 500 to 600 keywords which are already defined by us. So the implementation of all these keywords has already been done in Python, and which can be, so it doesn't matter what kind of implementation has been done, but when you have to test something using these keywords, it's just install Rasta in your environment and then copy paste these keywords or drag and drop the keywords into your test cases, and then it solves your test case purpose. So let's say you want to do an UI-based testing, you're going to log into the NSO UI and then check some XPath, and then you're going to use these keywords. Click on add button or click on object with XPath. So just reuse these keywords. That's what, and you can click on these HTML files. Oops. Okay. So these HTML files basically give you an example on how to use these keywords and what are the arguments that you need to pass when you use these keywords, and what exactly these variables mean and everything. So these pretty much cover all the interfaces which NSO currently supports, starting from REST, RESTconf, JSON RPC, and then something on the southbound. Like we have different kinds of devices, like a netcon device or CLI device. So how Rasta as a framework interacts with all such kind of device types. So all that has been abstracted to a keyword level, and all you have to do is to just pick the right keyword and then use in your robot files. That's what we're going to do now. So let's take an example of, if you can see my screen. Yeah. So this is the Git repository which I was showing earlier. What I'm going to do is I'm going to start with a very simple example. So I have a test bed. We represent a test bed in YAML format. That's the format which Rasta takes the inputs. Like you're going to say that before even starting writing your test cases, you're going to define your test bed. So that's what we're going to do here. So we have a CSR92 device, and then we say what kind of device it is, what is the IP address of it, and then give all the username passwords so that Rasta will read this file and then access all these details when you refer to this particular device in your test case. So this is a very simple robot file, which is actually reading this testbed.yaml, and I say that connect to device CSR92, and then execute show version or on the device CSR92, and then capture the output and then print that and on my HTML reports. That's what my test case is right now. So what I'm going to do is I'm going to put this test case in my Git repository and tests. Let's say unit tests. And then I'm going to upload my test bed as well. I'm going to push these results. Yeah, so now what happens is now when a change is pushed to your Git repository, you see that a build is already in progress. So now if your project starts with all the stages, starting from creating a Docker network and then creating an NSO Docker which is 4.6 for this project, and then download a particular NED, and then device under test. So this is where the testbed.yaml file gets formatted, and Rasta will pick up the device and execute that particular test case in this stage, Rasta test execution.
Very good. Can you round it off here?
Yeah, we can, sure. So we're going to stop this now? Or?
Our time is up, so we need to. You can have a few closing words. And
Yeah.
then we can 2 questions or so.
Sure. Okay. So, I think this is on a high level on how the pipelines and Rasta and different CI/CD tools stitch in together and put that as a platform. And when it comes to test reporting, this is how you're gonna see the test reports. So when this execute commands on device, you're gonna see that this is how the entire configuration gets pasted onto your HTML report, and you're gonna review your test cases and their outputs. Yeah, this is pretty much from my end, so I'm happy to have any questions. Yeah.
As I understand, you've come up with some kind of a language for Rasta framework, right? That describes the basic testing and setup steps. So I'm wondering whether you are using any kind of struct syntax tree analyzer, like NTLR, for instance, or it's just, for instance, regex-based solution or something like this.
You are asking based on the test case execution or the verification part?
The language parser.
Yeah, the language parser. So that's all the robot framework semantic. So nothing new. So we are using the robot framework semantics, saying that okay, this is how the format is. So that's how it's going to be. All that Rasta does is just enables you with all the keywords which are listed over here. So it's still the same robot framework, but it's just that the keywords are something native to NSO.
Yeah, and the reason we chose robot framework because it has a large support for many plugins. You can use Selenium, you can use HTTP, even netconf is there too as a part of the, or netconf CLI is there as a part of the plugin. It's all built in Python primarily, right? So and then you have this baseline framework, and on the top of that you create your resource files and you create your test cases. And in test cases can be anything, but if you're defining a test case or keyword that is not part of current your resource file, then you will have to define the corresponding function as well that's going to be implemented. And today we did everything using Python.
Thank you very much.
Yeah.
And the second question is, do you have any, I believe you have policies for running like long-running tests, short-running tests, for instance, unit and integration tests, like you, for instance, run integration tests only daily and unit tests during every build, or how it's defined on your site? Thanks.
So normally we do it with every check-in. So whenever there is a check-in, you're going to have a virtualized environment spun up, and then it will run off. So all our, I would say, integration tests and end-to-end tests are part of our Rasta framework. But then on top of that, users write their own unit tests as a part of their code building process as well. That which can be, if you're writing, the Java-based code for NSO, let's say. I'm not sure how many people are doing today with the Python out there. So, but you can write all the unit case, every part that would be executing as a part of your JUnit. As far as the scheduling goes, I don't know. We don't have done. We haven't not a year use case of doing a scheduling part for long running versus short running. But you have definitely you have a Jenkins which is going to take care of how long the job is going to run for, and it's going to keep tracking during the pipeline process. So, like I explained earlier, your pipeline process is nothing more than kind of like a tying in your stages and a task in a series of events, right? So this is where the Jenkins files did at, right? So.
Very good. Thank you very much. Prashanth, Rashid, thank you.
Thank you.
Thank you, guys.